Hello friends, welcome to the next lecture of powder metallurgy for the subject manufacturing process. In the previous lecture, we have seen what is meant by powder metallurgy, what are the processes involved in the powder metallurgy, and in those processes we have seen the three processes in major, that is first preparation of the powder, second one is mixing or blending of the powders, and third one is the compacting. Now the next process we will discuss today is sintering process. Sintering means heating. So here in this process the compacts, that means the parts which are produced from the compacting process, are called as compacts. These compacts are kept in the large furnace having controlled temperature. So these sintering process is governed by three important factors, that is what is the temperature, what is the time span, and what is the atmosphere. So actual value of sintering temperature for most material ranges between 70 to 80% of their melting point. What is meant by this? The material which you are selecting for the sintering, the sintering temperature for that material you have to keep between 70 to 80% of their melting point, except ceramics, because they require higher temperature than other materials. So we will see what are the stages of sintering. What exactly happens after compacting process? The compacts, that means the parts which are coming out after compacting process, are called as compacts. They contain volatile substances, lubricants and binders, and they should be burnt off. And in this first stage, this thing we are taking care of, that is burning of volatile substances, air, lubricants and binders, and after this the temperature you have to increase slowly. In the second stage, which is also called as high temperature zone, the temperature of the compact is raised to sintering temperature. As I told you, what sintering temperature you have to keep. Depending upon the material, the sintering temperature should be 70 to 80% of melting point. And at that sintering temperature, the part is held for sufficient time to have solid state diffusion and proper bonding between the particles. And after this, third stage consists of sintered parts are gradually cooled in the controlled atmosphere. This is how the sintering process goes on. First of all, this is the compact. First part is called as the compact. This green compact you are getting after compacting process, and when you start heating that compact, the next start forming, that is the gaps between the particles goes on decreasing and the particles get diffused, and fully centered part, that is fully heated part, is you are getting. So very well, from diagram A you can see the initial powder particles, and as the temperature increases, neck formation starting and diffusion takes place, and this diffusion is known as solid state diffusion. From this diagram you will very well come to know that how the diffusion process takes place. So what are the objectives of sintering? To achieve high strength of the compacted parts, to achieve high bonding of the particles, and the parts which you are producing should be free from oxides. The sintering environment, what is the known by sintering environment? It should not have undesirable reactions, reduction of surface oxides, controlled composition, managing the impurity levels. Some examples are shown over here. The other secondary processes used for this, one is sizing, coining and impregnation. In sizing, what is done? Placing the sintered parts in the die, that is the parts which are removed from the sinter, they are placed in the die, again repressed to correct the dimension and size. And during what happens actually in sintering process, there is a possibility of distortion. So to remove that distortion, sizing is to be done. So coining means it is similar to sizing, but here the purpose is to close the voids or gaps and provide desired density. Now impregnation is important. Here the parts are placed in the tanks containing the lubricants, and these are heated for sufficient period of time, let us say 11 to 20 minutes. After that, what happens? The lubricant enters in the pores of the parts. Also, this is a kind of self-lubrication. Another process is infiltration. What is meant by this? This process consists of placing a shaped piece of copper or brass on top of pre-sintered part. That means you have to keep a piece of copper or brass of the pre-sintered parts, and again you have to heat it. Then what will happen? Whatever the part you have kept on the top of the pre-sintered product will melt and enter into the pores of the parts. So this will increase strength, density and hardness of the parts. And lastly, plating. In this process, firstly impregnating parts, that means the parts you have to impregnate. You know what is meant by impregnation. That means dissolving in the tank, and that is a kind of self-lubrication. And here you have to impregnate the parts with plastic resin to fill up the pores, followed by usual plating procedure. So lastly, we will see what are the advantages of powder metallurgy. That is virtually unlimited choice of alloys, controlled porosity, can be very economical for large runs, long-term reliability, very good material utilization. What are the disadvantages? Limited in size, specially machines required, need to control environment, corrosion is the major factor. Then less well-known process, the dyes which you are using are costly. So these are some disadvantages. And finally, coming to the applications, you can make cutting tools and dies, that will mostly tungsten carbide, machinery parts, bearings and bushings, magnets and electrical parts. So friends, this is all about the powder metallurgy. So in the next lecture, we will discuss on the next unit. Till then, take care, stay at home. Thank you very much.